Okay, so next function, let's plot this one. So I want you to go do the normal things. I want you to go and figure out, looking at our position function, what do you know? So pause the video right now and do so. Okay, so here are the things that I know. So I know that there are vertical asymptotes when the denominator equals 0. So it equals 0 when x squared minus 9 equals 0, or when x equals plus or minus 3. So there are vertical asymptotes there. I also know that there is an x-intercept when, when x equals 0. What else do I know? Well, the degree of the numerator is smaller than the degree of the denominator, so I know that there's a horizontal asymptote at the line y equals 0. So that tells me the end behaviors, right? And we could have taken the limit for that, but we don't need to. So here is what I know so far. So what I know so far is I know there are vertical asymptotes at plus or minus 3. This is really hard to do, by the way, making dashed vertical lines on an iPad, so they don't look super good. I am sorry. Okay, and what else do I know? We know that at 0, there's an x-intercept. And we also know, and I'm going to just emphasize this, we know that the x-axis is not only the x-axis, but it is also a horizontal asymptote. So what else do we know? I actually know some other things too. So I'm going to look to the left and right of my vertical asymptotes. I'm just going to see what's going on there, just to get an idea, right? I can look at that. So as I approach, and again, these are things I'm doing. You don't necessarily have to do them, but I think they're useful. So I'm going to have x approach -3 from the right-hand side. Well, as it approaches from the right-hand side, I've got, what do I got here? So as it approaches from the right-hand side, so I'm looking this direction, right? Well, I've got a negative divided by a negative. So I've got a positive, right? So in other words, this thing, as it's moving closer and closer to that vertical asymptote from the right, its value is increasing forever and ever and ever. And then as I move from the left-hand side, as I approach from the left-hand side, right? So now I'm talking like negative numbers like -4. Now I've got a negative divided by a positive, so it's negative. So it's doing something like this. And then let's see, as I approach 3 from the left-hand side, right now I'm looking at that guy right there. And let me undo that so it's not confusing. What is it doing? So as I approach that one, it is, what is it doing? Well, it looks like it is going to be a positive divided by negative. So it is going down at that vertical asymptote. And then as I approach it from the right-hand side, so now I am approaching that vertical asymptote from the right. What is it doing? Well, it's going to be a positive, so it's going positive. Wow. I'm ready to take a guess. Like, I am seriously at this point already ready to take a guess based on what I know. So I'm not going to yet, but I'm ready. I'm ready to solve this puzzle. So if you don't mind, I'm going to erase the pink stuff, this stuff right here though. And you may have been able, maybe you did that, and it's kind of a good idea to do that. We should start getting comfortable with looking at values, right? We should be able to take limits as we approach certain numbers. That's all I did. I took a limit as I approached -3. I took a limit as I approached 3 from both left and right hand side. So we should be able to do that. But you know what? We can also get that from, we could probably look at that from another place too. Or it will get caught somewhere else. So let's take our derivative, and I'm going to give you the derivative. So please don't take your time taking the derivative. I'll do that for you. So this is my derivative. So what I want you to do once you've gotten the derivative is once I've given you the derivative, So I want you to go through and find the different things that we do from there. So pause the video and do so. Okay, so what you should have noticed right off the bat is that there are no critical values. We already were aware that it wasn't differentiable in the denominator because it wasn't continuous in the denominator. So we're already aware of that. We already know that we need to check what's going on at those vertical asymptotes. But what else does this function tell me? Well, there are no critical values because the numerator is never equal to 0. So the only thing that I know is that, well, let's see. What do I know? Well, I know that since there are no critical values, let's see what I know. Well, okay. I know that the numerator is always positive. Confirm it. The numerator is always, 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 no matter what I plug in, the numerator is positive. And I'm sorry. Wow. I'm wrong. So let's try that one more time. The numerator is not always positive. The numerator is always negative. Right? Confirm for yourself that that numerator is always negative. But it's always, always, always negative. And the denominator is always, always, always positive. Again, confirm those for yourself. Okay? So what does this tell me? Well, this tells me that this function is decreasing everywhere. It is just always, always, always decreasing. So, and you know what? I'm not super surprised. Because like I said, I was ready to solve this puzzle in the position function right away. So here's my solve. And again, I'm going to be checking, but this is my solve. Well, as I come from negative infinity to negative 3, well, there's a horizontal asymptote at 0 on, y equals 0. So it's going to do something like this, right? This is decreasing as I go from negative infinity to negative 3. Then from negative 3 to 3, it is still decreasing, right? It is still decreasing. So it's going to do something like this, right? It's going to do something like that. You know what I bet, though? I bet, and we'll find out, I'm betting at 0, though, that there's an inflection point. And I'll see, but that's my guess. And then finally, from 3 to infinity, it's going to go here, and it's going to hug the horizontal asymptote. So that is my guess. Notice the assumptions I made. I assumed, and I bet you I'm right, that it is concave down there. I assumed that it was concave up here and concave down here and concave up here. Those are assumptions that I've made. I'm pretty sure I'm right, and I'll be checking it through my second derivative, but I'm feeling pretty good. Now, absolutely we should go through and make a sign chart to confirm our graph, right? To confirm my intervals of increasing and decreasing, because I could be wrong. Absolutely, there's no question. So let's go and do that. So let's go and make our thing. So our values that are important are negative 3 and 3, and that's for our y prime. So to the left of it, again, don't forget we're plugging it into this. Well, guess what? I mean, it's kind of silly, but let's do it. From the left of it, well, it is negative. I shouldn't be surprised that it is negative, but because it's absolutely, because I have a negative divided by a positive. From between negative 3 and 3, it is, well, guess again, it is negative, shocker, and from the right of it is negative. So guess what? My graph, at least my sign chart agrees with my graph. Again, I shouldn't be too surprised by that. Let's go find the second derivative now. And again, don't go and take it. I will do the heavy lifting for you. So here's my second derivative. Okay, if you would please go and find the inflection points, if there are any. Pause the video. Okay, so hopefully you found your inflection points, and guess what? There should only be one inflection point, right? That inflection point, we already know about the denominator, so the only thing we have to worry about is that numerator, and there's an inflection point when x equals 0. And again, inflection points only happen when the function equals 0. So right here at x equals 0, there's an inflection point. So at the point 0, 0, which we have graphed, there's an inflection point. So what does this tell us? Well, it tells it pretty much confirms what we already knew, and that is that this thing, that there was an inflection point there. I said that I thought there was going to be an inflection point here, and my guess was right, is that it was going to be concave up here, and then it's going to go inflection point and then go concave down there. And there's really no other way to draw that. That's the way it's got to be. But we can check, right? That's our guess. Let's go and check. We also, right, we didn't check what's going on over here and here, even though the only inflection point that occurred was right here. So I really don't know what else those this left-hand branch and that right-hand branch could possibly be, but of course we should check. So let's see what's going on at 0. So to the left of 0, well, to the left of 0, it's definitely going to be negative, and you can confirm. And to the right of 0, it's definitely going to be positive. So what does that tell us? To the left of 0, everything should be sorry. Let's try that again. I did mess up a little bit, so I was going a little fast. What I forgot to do was put in those vertical asymptotes. I was making a quick assumption. So let's put in those vertical asymptotes. We can't forget them. I did, and I shouldn't have. But I do need to. I can't forget them. You just can't forget a vertical asymptote. So let's check those vertical asymptotes. So to the left of -3. Well, to the left of -3, I'm throwing in things like -1,000, and that's very definitely negative. To the right of -3, so I'm throwing in numbers like -1 at that point. Well, that's very definitely positive. Now to the right, guess what? It's going to be positive divided by negative, so it's going to be negative, and then finally to the right of it, it's going to be positive. So this tells me that it is, well, concave down, concave up, concave down, concave up. So let's see. To the left of -3, is our graph concave down? You bet it is. Between -3 and 0, is it concave up? You bet it is. From 0 to 3, is it concave down? You know it. You bet it is. And from 3 to positive infinity, is it concave up? You bet it is.